Alrighty, so we are going to continue to talk about composite functions today. We saw composite functions yesterday as well, and we were evaluating at a specific value. Okay, up here with me, you guys. We were evaluating at a specific value yesterday, like what you see for these first couple of problems. So I want to start there, a little refresher of what we've already talked about. So I've got f of x and g of x up here at the top. If I want f of g of -5, remember we work from the inside out. So I have to start with what is g of -5. So g of -5 would be -5 squared minus 7, 25 minus 7 then, and we would get 18. So g of -5 gives us 18. And now I have to find f of 18. So f of x is x plus 2. This would be 18 plus 2. So we get 20. So remember, our answer for what is f of g of -5 is 20. This is what we worked on yesterday. Second one, same idea. Different value, a little bit different order. We're taking our functions, but same idea. So g of f of 3. So I start with what is f of 3. So f of 3 would be 3 plus 2. So we get 5 there. And now I have to find g of 5. The output for this function is the input for my next one. So this would be 5 squared minus 7. This looks familiar. 25 minus 7 gives us 18. So g of f of 3 is 18. Does this look familiar? Yesterday? Right. Okay. And I think yesterday we looked at all compositions where I was using more than one function, f of g or g of f or h of k or whatever the functions were called. I can do composition with the same function. That's fine. Like our next one, g of 0. So this would be find g of 0. So g of 0 would be 0 squared minus 7. That's -7. And then I find g of -7. So this would be -7 squared minus 7. Same idea, a little weird maybe that we did g of g. But I evaluate the same way. Here's the thing that we're going to look at that's going to be a little bit different today. Instead of just looking at evaluating at a number, we're going to look at evaluating at an expression, okay? So for our next function, this is not a composition. We're just going to look at f of x plus 4, right? Not g of f of or f of g of x plus 4, but just f of x plus 4, just to kind of get a feel for what we're going to look at for today, okay? So I'm going to evaluate f at the expression x plus 4. So this means anywhere that I see x, I am going to plug in x plus 4. Just like here, anywhere I saw x, I plugged in 3. This time, anywhere I see x, I'm going to plug in x plus 4 for my function f of x. So this would be x plus 4 plus 2. So as I simplify, we get x plus 6. So f of x plus 4 equals x plus 6. A little weird, but are you guys with me still? Okay. We're going to do the same thing again. This time we're going to do g of 2x. So g of x is x squared minus 7. So instead of x here, I'm going to put 2x. So this would be 2x squared minus 7. Instead of x squared, I have 2x. Be careful when you square here. I squared the 2 and get 4x squared. minus 7. So g of 2x is 4x squared minus 7. Questions for me so far? We're going to do another one like this. So f of x squared minus 10. So this would be x squared minus 10 plus 2. Combine your like terms so that we have our simplified function. F of x squared minus 10 would be x squared minus 8. Now we're going to look at a composition. Okay. Notice it's f of g of x. There's no value I'm plugging in this time. We're going to keep the x. Okay. So we're going to approach these a little bit differently at the beginning. Because I'm not plugging a value into g, I'm going to keep it as x. There's actually not like our first step before, there's not a thing for me to do there. Like here, I had to plug in 0 for x and then figure out what that value was. But we're keeping the x this time. So I don't have to do that first plug-in step because it's already written in terms of x. Okay, so that's how these are a little bit different. So what's g of x? Well, it's just this thing. I don't need to change it or plug anything in. It's already written that way. So now I'm going to go to the f of part. Okay. So anywhere I see an x in f, I'm going to plug in g of x. So that would be, let's see, x squared minus 7 plus 2. And since f is a linear function and the slope is just 1, there's not anything crazy I need to do here. Again, just combine my like terms. So f of g of x would be x squared minus 5. Questions for me so far? Now we're going to do g of f of x. So we're swapping the order on f and g. Which one is my sort of inside? So again, since it's f of x, I don't need to do anything different, okay? Or I don't need to plug in any values. It's just x. It's not going to be any different. So my f of x is just x plus 2. And now I plug this into g. Okay. So I have x plus 2 squared minus 7. I took what I got from here and plugged it in for x in the other function. Okay. Now I'm going to distribute, combine like terms, tidy it up, all that fun stuff. Okay. Another mistake I see pretty frequently when I'm squaring x plus 2, that is not the same as when I squared 2x. This was multiplication. Okay. This is addition. When I'm squaring things that I'm adding here, this binomial that I've got here, that means I am doing x plus 2 times x plus 2. I was also doing that up here, 2x times 2x. But since there's no addition or subtraction, there's no distribution that I need to worry about there. There is distribution here, so make sure you're careful with that. Okay. So this guy would give me x squared plus 2x would be plus 4x plus 4 minus 7. And then combine your like terms. X squared plus 4x minus 3. So g of f of x squared plus 4x minus 3. Questions for me so far? We feel okay about this so far? Not too bad? Okay. On the next page, we're going to do this some more. It's a new function, but we're doing the same thing. Compositions where I'm not necessarily plugging in a value. So on the next page, same idea. We've got two new functions, a new f of x and a new g of x. but same idea. Okay. I'm going to work through a couple more with you, and then I'm going to ask you to try. So let's try our first one. F of x. F of x, we know, is x squared plus 1. Okay. Exactly the same thing I've written here. It's already f of x, right? I didn't plug anything in. I wanted to keep the x. So now f of this thing means if I wanted to, if it's helpful to you, you can write that you're taking f of x squared plus 1 for the next part. So that means anywhere I see an x, I'm plugging in x squared plus 1. So this would be x squared plus 1 squared plus 1. Again, I've got a binomial here, so remember that you are distributing. So this would be x to the 4th plus x squared, so 2x squared plus 1 plus 1. So you get x to the 4th plus 2x squared plus 2. F of g of 3. This is back to what we talked about yesterday. I have a number there. I have a value for x. I'm going to plug in that value for x. Work from the inside out. So g of 3 would be the square root of 3 plus 2. That's the square root of 5. I'm going to leave it as the square root of 5 since it doesn't simplify to a nice number. And then I'm going to find f of the square root of 5. So that would be the square root of 5 squared plus 1. What happens when I square the square root of 5? I get just 5, right? So we would get 6 here. Questions for me so far on page 18? Alrighty, let's keep going. F of g of 3x squared. So I'm going to start with g. Anywhere I see an x, I'm going to plug in 3x squared. So this would be the square root of 3x squared plus 2. And that is all under the root. And then I'm just going to leave this. This is something I can simplify nicely at this point. It looks messy, but that's okay. I'm just going to leave it as it is. And this is what I will plug into f now. So I'm taking f of this thing. That means I get the square root of 3x squared plus 2 squared plus 1. Right? I just plugged this in for x in f of x. The nice thing here, just like our last problem, I'm squaring a square root. So I'm left just with what's under the root. So this is 3x squared plus 2 plus 1. And then combine your like terms to tidy this up. 3x squared plus 3. For today, you can just do that. Just make sure that I can tell where your final like answer is. Does that make sense? I would like you now to try the next 1, 2, 3, 4. Try the next 4. when we've got those like exponent rules kicking in, right? Can you remind me what you're squaring? Squaring or so I'm writing this up just so we remember that we'll next four. So you're saying x cubed times x cubed. So you had it written up. Well, we're not. Well, we're not going to do that. Yeah, we're just writing that. Alrighty, let's take a look at these. So f of x plus 7, that means in f of x, I'm replacing x with x plus 7. Be careful with your distribution here. When we square, you should get x squared plus 14x plus 49 plus 1. So x squared plus 14x plus 50. This is what you should have for the first one I asked you to try. Yes, you do have to distribute this out. For the next one, f of 4x cubed, this would be 4x cubed squared plus 1. This would be 16x to the 6th plus 1. F of g of x, so g of x is the square root of x plus 2. Now if I take f of that, I'm going to square that part and add 1. Square and square root. I mean, we just have x plus 2 plus 1, so x plus 3. And then g of f of x is x squared plus 1. And then when I take g of that, we get the square root of x squared plus 1 plus 2. So that would be the square root of x squared plus 3. Can I simplify this to x plus the square root of 3? No. Okay. I'm adding here, so I cannot separate these out into separate roots. If it were 3 times x squared, all under a square root, then we could break them up. But since we're adding under that root, we cannot separate these. Questions for me so far? Alrighty, turn the page for me. Alrighty, new function here. A lot of the same types of things we just did, okay? Evaluating at expressions instead of numerical values. But we're kind of building up to something here. So if we look at our first problem, 3x plus 5. If I want to evaluate at the expression x plus 2, okay, I would have 3 times x plus 2 plus 5. And then we could distribute, and we get 3x plus 6 plus 5. So 3x plus 11. That's f of x plus 2. Could have given you this problem on the last page. Same idea. Slightly different idea. What if it's x plus h instead of x plus 2? Does that change how I approach the problem? No, same idea. So this would be 3 times x plus h plus 5. Distribute, just like before, 3x plus 3h plus 5. The only difference here is I don't have any like terms to combine. For our next problem, we saw something kind of like this on our first quiz where I asked you to evaluate for different values and then subtract those values. And I think we even did like 3 f of 2 minus 4 g of something. So similar to that idea, I'm going to find f of 4. So that would be 3 times 4 plus 5. And then I'm going to subtract f of 0, which would be 3 times 0 plus 5. So this would be 12 plus 5, which is 17. This is 0 plus 5, which is 5. So I have 17 minus 5, and we get 12. Reasonable? Stuff you guys can do? Use the stuff that we've done already? Same idea, but this time, instead of actually giving you values here, I'm saying x and something different than x plus h, whatever that is. Presumably, as long as h is a positive value, this is a bigger number minus a smaller number. Okay, just like here, bigger number minus a smaller number. So we know that f of x plus h is this guy, right? 3x plus 3h plus 5. I'm stealing that from the problem above. And now I want to subtract f of x, which we know is 3x plus 5. So this would be 3x plus 3h plus 5 minus 3x minus 5. I do have like terms to combine this time. 3x minus 3x means no more x terms. 5 minus 5 means those are gone as well. All I have left here is 3h. Questions for me on this one? This is a little weird. Okay. So the difference between my function at x and my function at some number bigger than x is 3 times whatever that h value was. Notice that kind of tracks with what we saw here when we plugged in actual values. The difference between my function at 0 and my function at 4, right? If x equals 0, that means h was 4, 3 times my h value, 3 times 4. Now we're going to look at one more thing, both with numbers and with that x plus h vibe, right? That x plus h stuff that we're doing. So function value at 3, that would be 3 times 3 plus 5 minus function value at 1, 3 times 1 plus 5, all over 3, all over that first value that we're plugging in. So this would be 9. 9 plus 5 is 14. 3 plus 5 is 8. So we get 14 minus 8 divided by 3. That would just be, this is 6 to 2. We're going to look at the same thing now with those variables. in there, right? And placeholders. F of x plus h, we know, is 3x plus 3h plus 5 minus, we know f of x is 3x plus 5. Right? And then all over h. Now this top portion we've already done. We know that that's just 3h. Can I reduce 3h over h? Sure thing. What would I get? 3, right? I can reduce the h's with the caveat that h cannot be 0. H cannot be 0. Otherwise, this is undefined. But this takes something really nasty and simplifies it down to something pretty manageable, right? What we just did here is something that you will use in your future courses called the difference quotient. Some of the stuff that we are going to talk about next week, I think we'll get to it. We're going to kind of call back to this difference quotient idea and talk about what am I actually like looking at here. For today, I just want to introduce this like term and this idea to you that this is what we call the difference quotient. Okay. And it relies on this sort of evaluating and at an expression piece that we've done. So I would like you now to find the difference quotient for this function. New function, same setup. Find this for our new f of x. Okay, let's take a look. F of x plus h. That would be x plus h squared minus 5 minus f of x, which is x squared minus 5. All over h. Be careful with your squaring. Be careful with your signs. So x squared plus h, or x plus h squared, there we go, would be x squared plus 2xh plus h squared. And then when I combine like terms here, I would have x squared plus 2xh plus h squared minus 5. There really isn't any combining I can do at that point. Over here, there's nothing for me to do except for make sure I distribute through, if you think of it as distribute through -1 or distribute through your subtraction, so we'd have minus x squared plus 5. From here, there's some simplifying I can do, combining like terms. X squared minus x squared, -5 plus 5. So we get 2xh plus h squared over h. Raise your hand if you got to here. Okay. Am I done? I can simplify some more, right? I've got an h I can factor out on the top. That would leave me with 2x plus h over h. We can reduce our h's, and we get 2x plus h. This is something, again, that is not a like huge focus in Algebra 2, but it is something that you're going to see probably at some point in pre-calc, definitely something you'll use in calculus. Okay. One more thing for today. Turn the page for me. The last thing we're going to do is, again, another idea that you'll end up using in calculus, but I want to sort of set the stage for that here, kind of plant the seeds here. So composition of functions, where I took a function and I plugged it in for another function. That's what we did today. I took f of x and I plugged it in for x in g of x, and I got usually kind of a more complicated function. I can also decompose functions. So I can take a function that is maybe a little more complex and write it as a composition of two usually simpler functions. So here's what this could look like. And there's more than one way that you can do this for the functions that I'm going to give you, but here's what this could look like. So let's say this is my function f of x. Okay, I've got the square root of 5 minus x squared. I could write a function g of x that is just the square root of x. And then I could write a function, I'm going to call it h of x. As long as we're not using f, can't be the name of the original function. Okay. I could write a function h of x that's 5 minus x squared. And then I can say that f of x is just a composition of those two functions. It would be g of h of x. Because I would take h of x and plug this in for x in g, and then that would get me f of x. Okay. It's called decomposing functions. D is a little extra nasty, right? It's a fraction, and then on the bottom, I've got a square root, and inside the square root is more stuff. So if I wanted to, I could write this as a composition of functions instead. So g of x, let's say, is 4 over 3 minus x. And then let's let h of x be the square root. So then f of x is just the composition g of x, or g of h of x, I should say. I take h of x and I put it in for x in g of x, and that's how I got f of x. Mm-hmm. So you let your h of x do this, and then what was your g of x? So you wrote a composition, but yours looked different than mine, right? Mm-hmm. Say that for me again. I don't think so, but I'll double check. Okay. So you wrote a different decomposition, I guess, the function. Does yours give you the same f of x? Yeah, that's okay. There's more than one way I could decompose functions. You can also use more than two functions. So the last thing I would like you to try is to take b, split it up into three functions. So that if I did, let's say, g of h of k of x, I would get back to f of x. Okay? That's the last thing I want you to try for today. After you've written your function, compare with a neighbor.